And we are live. So welcome to today's session. We are going to do Cloud Native Tech Talk. It's a new thing that we're trying out, which is going to be, sorry about that, hang on. I happen to have the stream in my background and I started talking over myself. That's super confusing. So what is going to happen is what the Cloud Native Tech Talk, Nordics Tech Talk is that it is going to be a technical presentation. And after the presentation, there will be time for questions, etc. if you have any questions for the presenters. And this is a follow-up. We're trying like new formats every time. Last time we did Cloud Native Nordics stories, which is about different people joining and telling their Cloud Native story. My name is Jessica. I am a CNCF ambassador. I also work as an infrastructure engineer at Meltwater. And these are my teammates. So why don't you introduce yourself?
Hi, everybody. My name is Simone Sciarrati. I work with Jessica and Federico in the Bravo team in Meltwater. I've been part of Meltwater for more than 5 years now. And in Bravo, we provide Kubernetes as a service, and we are gonna talk a bit about it. Federico.
Hi, I'm Federico. I'm colleague to Jessica and Simone. I also do infrastructure engineering, focusing on Kubernetes and a few other things. So let's get started, and I will share my screen now. And hopefully you will see a few slides here now. So yeah, we're going to talk about.
Before you start, can you maximize it so we don't see the border?
Should be better now.
Perfect, thank you.
Good, yeah. We're going to talk about how we tested scalability in Kubernetes. Meltwater, we're doing media monitoring. We collect different content, editorial content, social content, other content, enrich it, store it, and provide it to our customers. They can do search, reports, and alerts. And we've been around for a while. All this is done by 350 plus engineers, and we are spread out to 9+ offices around the globe. We're heavily using AWS and Kubernetes since 2018, early 2018 in production. This was at the end of 2018, our production cluster. We had around 280 applications deployed to it. They are exposed to 150 services, 70 nodes, and then basically every 5 to 6 months, the size of the cluster doubled. And right now we're at this stage, as you can see, between October and now, the number of applications has not increased that much, but the number of pods, teams have been increasingly using the HPA to dynamically scale up and scale down the applications. So while this happened, and we started with a small house, small cottage, providing Kubernetes as a service to the other teams, and this became bigger, an apartment building and now a skyscraper, we were wondering if the architecture of our Kubernetes cluster could work with this increased usage. And we wanted to avoid being part of these Kubernetes failure stories that Henning Jacob at Zalando collects. So we were thinking, when will we hit some of the Kubernetes limits with our increase in the cluster, and how can we test this? So going out to the official Kubernetes documentation, you can see some numbers here for the different sections, nodes, namespaces, number of pods, and the thresholds are divided between namespace and for the entire cluster. So you can see the official limit is 5,000 nodes, 10,000 namespaces, and then either 3,000 ports per namespace or 150,000 ports for the entire cluster. And depending on how you deploy these, into several namespaces or few namespaces or more namespaces, this is a multi-dimensional problem where you drag this cube into one edge, the other numbers change and might become smaller or bigger. What you can also see in this table is that there are a lot of these thresholds that are not yet defined. So there is no official number on the what you can put as daemon sets into your cluster or namespace, what number of jobs you can run in your cluster, or for example, how many stateful sets the official threshold is for the cluster. So while we have these official numbers here, there are a few SLOs that the Kubernetes project guarantees. So in the documentation, it's stated that when you do an kubectl apply call that mutates something in the cluster, the latency for this should be less than 1 second. Also, the startup latency of stateless pods should be less than 5 seconds. You will also find that a few of these SLOs are not yet defined. For example, the programming of the internal DNS service. The 99th percentile, what the value should be there, how fast kubedns is programmed, it's not defined yet. Also, network latency or the startup latency of stateful pods, it's not defined. While we have a few of these SLOs that are defined, there are a few conditions that should be met to get these and guarantee these SLOs. One of them is that you should run a single or more sized masters. And the sizing of the masters is also documented in the Kubernetes documentation. For each number of nodes in the cluster, they suggest what kind of instance types you should run either on Amazon or in Google. And for us, we were following those and we sized our test cluster accordingly to this documentation. Another condition is that you should split up etcd into 2 separate instances, one for the state and one for the events. And we also set up the scalability test cluster with this COPS support, this way of doing etcd. It's also stated that the etcd instances, they should run on the master. The SLOs are guaranteed only under the circumstance, not running etcd separate from your masters. Another condition is regarding the cluster churn. Cluster churn is the number of pods being created, updated, or deleted. And there is a limit on that. So a maximum of 20 pods per second can be updated, created, or deleted. This guarantees the SLOs that we saw previously. And to do that, and also generate this kind of traffic in the cluster, we created a tool that Simone will later on talk about. This is something also to measure what is going on in your cluster. Do you have a churn that is more than this or less than this? So when we say we want to test the cluster, we have the Kubernetes core components. We have the API server, we have the running on the master, we have the scheduler, we have etcd. Then we have the components running on the nodes. We have kubeproxy and we have the kubelet. So this is part of the scalability tests. How good are these core components behaving when we scale up the cluster? But there's much more that we're actually testing when we bring up the cluster and put some load on it. It's all these additional components that are part of the cluster that we provide to the other teams. Prometheus and Thanos collecting metrics. We use DEX for the login. We also give teams ingress possibilities with the Nginx ingress controller that you put into the cluster that provides additional user experience and that your teams are using. So we now know the official numbers that Kubernetes project supports. We know the SLOs. We know which components we are testing. And with this, we then came up with a test strategy. What do we want to test? The cluster size, we have the utilization, we have these numbers that I presented you, and then we came up with a test strategy where we wanted to increase the number of nodes. We wanted to increase the number of namespaces in the cluster. We also wanted to increase the number of deployments per namespace in the cluster. So we went from doubling the number of nodes, doubling the namespaces, and the final test was 4 times the number of nodes, 2 times the number of namespaces, and 2 times the number of deployments per namespace that from where we started. And we wanted to see on these 4 tests, how good is Kubernetes behaving at the end. To do that, we could just run the test, but we want to know how good things are behaving. We need to measure. We need to measure the state of the cluster. We need to measure what's going on in there. And for that, we have been creating a couple of dashboards, collecting metrics that we found interesting and important to know. And I will give you a quick run through those. Later on, Simone will show you the interesting parts when doing the tests. So we will see these metrics twice and makes it easier and to see how we're doing with these. And for that, I will access this presentation and switch over to a Grafana dashboard and walk you quickly through those metrics. So we started with the getting information on the Kubernetes cluster state using kubestate metrics, wanting to know the number of pods, deployments, and so on that we have in the cluster. Important also is that we wanted to know the usage. What is the cluster officially possible to run on pods, and how many of these pods are currently running, and then how many of these pods are pending. We also wanted to know how is the cluster, the nodes in the cluster are doing. We use a cluster autoscaler for this. When are nodes starting to run, and when are they ready and have joined the cluster. The same is for the number of deployments and services, so that we can correlate all these values, and in particular, for kubeproxy. Kubeproxy programs IP tables and makes your services available to the outside. So we wanted to know how fast is kubeproxy programming IP tables, and there are metrics for that as well. One important thing is we use the Amazon CNI plugin to give the pods native IP addresses, and for that, you need to do a good IP plan to see that you have sufficient IP addresses. And we wanted to see how many of these are we using. Are the subnets too small, or are we have we capacity left? The same is then regarding the network. The nodes are consume elastic network interfaces from Amazon. In the end, you see here metrics regarding etcd. Etcd stores the state of the cluster. Each time we add nodes and deployments, they need to be stored. And here we have a couple of metrics indicating the state of etcd for each of the masters. And later on, We even have further down here metrics regarding CPU and memory usage of the masters. Each of the masters runs the master nodes runs the components, the API server, the controller, and the scheduler, and they're going to consume a good amount of CPU and memory. And last but not least, we have the SLO values regarding startup times for the different pods. And we wanted to see also how fast are the services, the endpoints available. So these are the metrics that we collected during our tests, and how we did the tests. That is something that Simone will tell you about. So I'm going to switch the presentation over to him.
Thank you. Let me share my screen. I hope you can see that. So what are we using as our testing equipment? We have our production cluster that is the baseline for what it is that we're running right now. We have what we call a control cluster. It's basically an instance where we develop Kubernetes itself. And then we need to build our test cluster. The test cluster is relatively easy to build. We have a templated way to generate a new cluster with COPS. As Federico mentioned, we need to be a bit careful and do some calculations in order to allocate enough IPs depending on the test that we want to perform. In the test cluster, we use smaller instances than we use in the production cluster to save on cost. But we choose instances that can allocate the same amount of ENIs and therefore IPs, so that we can reproduce the amount of pods that can land on a node. By default, we store all the CloudTrail logs, so all the API calls that we make to Amazon in our Elk stack, which we happen to manage ourselves as well for the company. And on top of it, in the new test cluster, we deploy all the kind of cluster-wide services that we provide, like Prometheus, DEX, Cluster Autoscaler, Kube State Metrics, Ingress Controller, External DNS, and so on, all the components that we want to test. The second step is to basically reproduce what we have in production as the baseline. And we do this with a job that checks what we are currently running in the production cluster. And it gives us a suggestion on what we should create. It also, so we can tweak any of these of the parameters. So we can tweak the amount of namespaces, pods per deployments per namespace, ingresses, and so on. And then the tool can generate all the configuration for us that we can push to the test cluster. And on top of this, we use pod anti-affinity for all deployments, and we set the resource requests to try to maximize the resources that we have in the cluster to mimic like a real environment and to exercise the scheduler. Once we have the baseline, what we do is that we deploy a small application that generates churn. It's deployed itself as a deployment in Kubernetes in the test cluster. And each replica will be in charge of creating a deployment, modifying a deployment, terminating a deployment. And each of these deployments that are generated can have a configurable amount of pods. This way we can generate any amount of churn that we want. And we expose metrics about how long it takes to execute all of these operations. We also want to mimic what the user would be doing while we do all these tests. So we have 4 control deployments that, for lack of better creativity, we call with color names. And they do different things. They generally do, the normal cycle is to create a deployment, then change something, maybe the image size, maybe the image type, maybe the number of replicas, and then verifying that every operation is concluded successfully, and then expose the metrics about it. One important one of these control deployments actually creates a new service and ingress, and therefore exercises, for example, external DNS. And then we verify that the DNS and the ingress that is created matches the ELB that is created in Amazon. All of these, then we gather all the metrics in Prometheus. And last but not least, we then generate some HTTP load. So we run a slightly modified version of Hey, which is a very simple load generator. We send get requests to a certain amount of deployments, and we try to reproduce more or less what we have in the test cluster, in the production cluster. As we do any operation and any test, we send annotations to Grafana. It's either something we can do it while as observations, so ad hoc, or we, some of the operations when we start to test, they are sent automatically to Grafana. So it wasn't easy to get to actually be able to test the 4x scale, because along the way we broke a few things. We had cluster autoscaler running out of memory. We had kube state metrics running out of memory. Prometheus broke Grafana external DNS. And by breaking, I mean that we had to tune the resources that were allocated, because as the cluster grew, they just consumed more, obviously, and we run into these issues. So what I want to show now is some metrics and some of the dashboards that I was talking about before. And for that, I will switch to this dashboard. I hope you can see it. So this is one of the tests that we run. The last one when we got from I think we got from about 800 nodes to 1200 nodes. This is like 4 times what we're running in production. So as you can see, we annotate the start of the test. So at this point, we pushed configuration for 3,600 deployments. Took us a bit of time to push it. And then we also increased the amount of ingresses resources that we had created for the namespaces. And the interesting information that we get for this graph is that we can obviously see a huge increase in pending pods, because we didn't scale the nodes of the cluster in advance. We just let the cluster autoscaler do its job, so we could test that it was actually working. And it takes a lot of time. We have also 5 daemon sets per node, so that takes time to deploy on top of actually deploying what we asked the cluster to run. You can see here where the nodes go up that are not ready, and then they slowly flattens and we get to a stable situation, and the same for the deployments. Now we can see a bit more metrics here compared to what Federico was showing. And we can see here that we have some outliers. Some programming actions took up to 5 minutes, up to 8 minutes maybe, which is really a very long time. While the basic sync, takes 1 to 2 seconds. This information was very valuable to us. And then we have an overview of how many IPs were allocated, how close we are to the capacity, and so on. We can see that this produces a bit of stress on etcd. So we have a few proposals pending, but after that, the situation goes back to normal. And this is, you can see it on the other metrics as well. It's obvious that it's doing more work, but overall, it's not really sweating that much. And if we go down to the masters, actually an interesting part is also SkyDNS, like the kubeDNS. We can see that with a larger amount of nodes, we automatically scale up, which is nice. But we also see that at some point, some of them die. And we haven't actually investigated yet this, but it's interesting to see the reaction of kubedns as well. So Federico mentioned that we sized the master according to the documentation, and that was good because you can see that here we actually went all up to the maximum CPU that we could actually run. We almost exhausted the capacity. And it's interesting to see that a big part of this on one master is the kube scheduler, and the other one is the controller that actually have to do a lot of work, but also it looks like at different times. And down to the to the SLOs, we see obviously that during this exercise, it takes a lot more time to start a pod. But overall, after this, when the size of the cluster is stable, things go pretty much back to normal. So the SLOs are actually respected. And operations, for example, listing pods obviously takes longer because now we have many more pods to list. From the point of view of a user, we have the deployments, the control deployments that we test. So we can see here that if I was a user trying to deploy, at this point in time, it would take me a very long time to get my application deployed. These are the 4 control deployments that we run, and they do different tasks. And here is the churn, the metrics for the churn deployments. We can see that in the initial part here, we get many less deployments per minute, and then the situation goes back to normal. And the last part of this dashboard shows the load tests. And you can see that we're running about 1,600 requests per second. And you can also see that we have a fair amount of 504s. They are climbing up. So the interesting part is that if we look at the Nginx corresponding dashboard, we don't see any of the 504s, apart from actually Prometheus breaking. So that's the small one here in the bottom line. Oh God, this is terrible. Here, but other than that, we don't actually really see any error. So that gave us the inspiration to do a bit more research in there. And what we wanted to test is if right now we run as an external traffic policy cluster, but we wanted to try to switch to policy local and see if that would help. So this is a dashboard of same test cluster, but a different time. And we run pretty much the same test. We have about the same amount of nodes and the same amount of deployments. And here what we do is we start ramping up the ingresses and the load tests. An interesting thing here that we noticed when we change the external traffic policies that we don't have those very bad outliers. So there is less programming that is going on, or it's actually more efficient. The average is still the same for the sync. And if we look at the point of view of the user, of course, there is an initial dip where we are deploying a lot of applications. But the interesting part is here. We go from 1,600, which was the previous test, and we scale up to 4,000 requests per second. And at this point, we had 0 504s. So that seemed to have resolved that issue. And obviously also on the Nginx side, we're showing like just successes, and there is no 504s. So going back to the presentation. So what did we learn? We learned that if we follow the documentation, if we do some work about sizing correctly, and not just the Kubernetes moving parts, but also the add-ons, then stuff generally works. But if we don't do that, if we don't do some performance tuning, then the user experience can degrade very quickly. We came out of this with a to-do list. We wanted to move the add-ons to dedicated nodes. We use instance groups to separate workloads in Kubernetes, and we don't want these add-ons to fight with other deployments. We might look into sharding cube state metrics. The AWS CNI plugin was pretty greedy. You know, it was pre-allocating ENIs and IPs, and we might look into Cilium or to tune that. We want to resource tune the cluster autoscaler, metric service, and obviously we want to look more into the external traffic policy local because it seemed to have a very good effect on our 504s. The next step for the test itself, we want to make it easier. Not everyone is now like something we can, not every one of these test deployments is something that we can run in Kubernetes as a deployable, which would be very convenient. We want to make good use of the API calls logs that we have, that we gather from CloudTrail to verify if new versions of components like the AWS CNI would cause more or less AWS calls. We want to do proper testing of DNS, and we want to test resources more than just deployments, ingresses, and services, and obviously reduce cost of running a test. So we might look into running this as spot instances. And I think with that, we're done. Thank you.
Awesome. Thank you so much. I would say it's very interesting, but I know part of this since before, right? So I think this is a perfect time if we have any questions from the audience, like anyone wants to know more about something. I'm trying to cover like Slack, I'm trying to cover Twitter, and I'm covering the YouTube chats. So if you have any questions, feel free. So we have one question coming in from Edwin. Did you calculate how much this test costed?
Yes, but I cannot remember. But we knew that we were running this, we knew the amount of instances we were going to run in the end. And we knew how long more or less it would last. And we also took care of taking down the infrastructure, the unneeded infrastructure every evening when we would go home. It took us, I think, 7 days, a full week to run this. And it's, I don't have the number right now.
But we could have an upper limit, say 8 hours per day, and the number of instances times what they cost.
Yeah.
Cool. So we have another one. So the question is coming in from Casper. He wonders experiences with AWS CNI in general.
It is a love-hate relationship. There are times it's just working, and we had times where we're experiencing weird bugs and weird things happening. It has improved over time, but it's still at some points it requires more tuning if we want to scale up or do things in a smarter way to not run out of resources. And I think looking at Cilium would also be a good alternative if you are needing native IP addresses.
We hope that answered your question. So what else? Any more additional questions? So we have a follow-up questions, I think. say from Casper again, did you have problems with the limitations on the network interface and the number of pods you are able to run on each machine because of the IP limits?
No. I think we could do some calculation on how many pods we were running. But we set for those instances, we can run up to 100 pods, and we were far below that number.
Yeah, there's the limit coming from either 100 pods per node or from how many ENIs you can attach to the node, and then how many IP addresses each ENI supports. From that, and then knowing the number of nodes we wanted to run and the number of pods we wanted to have in the end, the problem was then to create big enough subnets and make them available in the VPC. But after that, we had not any problems at all.
But I mean, historically, we have been struggling a bit. When we started out, we were very much limited by the number of pods we can run per instance, and we had to like add custom configuration for that.
Yes.
And also, we assign resources requests to the pods, so we wouldn't be able to run more than a node would be able to support, basically, in the load test.
Okay, more questions. I'm trying to scan everywhere. I think we're mainly getting the questions in through the YouTube chat, which is great. And I mean, if anyone has more questions, if they're watching the stream afterwards, they can reach out to us on Twitter, or they can reach out in Slack if they want to know more. And I assume we would be happy to tell you more about what we're trying out. Yeah. So we have one more question coming in. How did you break the Kubernetes dashboard?
It was very slow. It was extremely slow to load, especially in views where you would ask for a lot of information, like on pods or nodes. And to that, we actually looked into Octant to see if it would provide a better user experience. And it did. It was much more responsive. So that's another thing that we came up with. Look into that, into like either the future, the new dashboard 2.0, whenever that is available, or Octant or other alternatives.
I mean, the dashboard needs to fetch the metrics from Heapster or the metric server, and those internally then ask the Kubernetes API. And it just takes so much time to collect all those resources and the information. It's basically the same as well for Heapster metrics. One instance is not powerful enough to collect all the stuff for all the nodes, all the pods, all the services, everything that there is.
Did you consider like checking out, I know there's a few different Kubernetes dashboards that can run locally. I know Ola tried out one that you can run in your own terminal. Did you try these for the load tests?
Yeah, that was Octant.
Oh, Octant is a local. Cool.
Yes. Sorry
about that.
But also, I mean, just to clarify, we only tested the dashboard because that's what we provide nowadays. So we want to see how that would react to the load, to the increased size of the cluster and workloads.
Yes, so to know if that's something that we can continue using. So we have another question. What is the next target? Is it 10 times, 50 times? Where does it end, I guess?
It's a good question, but we started actually thinking that it's good to know that you can scale to that size if you need to. But there is other consideration. Is like the picture that Federico showed in the beginning with the 3 different houses. Is it also needs to be manageable. And whenever we do a cluster upgrade, for example, we have to roll those nodes. And if we have 1,000, it's difficult. Now it takes more time, or the logistics of it is a bit more complicated. So we are actually considering if moving to multi-cluster rather than having larger clusters. But this is a discussion that is very much in progress right now.
I see the other question regarding which components would break. I guess parts of the tests that we wanted to see and that we have not measured that much is DNS and how fast can DNS provide the new information that is requested when you do with the churn adding new applications to it and make them discoverable. The other thing is, can DNS support the number of requests that will happen in the cluster? And apart from DNS, as I showed you, our cluster increased or doubled the size every 5 to 6 months. But the last couple of months, we have seen an increased usage of the HPA. So that is something else that we haven't tested it. What happens if suddenly you don't not only have perhaps 100 HPAs configured, but if there are 500 HPAs in the cluster, can the metric server or the custom metric server give the HPA all the information that it needs to calculate the scaling? So I would assume that the HPA will start to get into problems.
Cool. We have another question. Unless Simone, you wanted to have something more to add to that. Do you see kops as your primary tool for managing Kubernetes going forward, or are you looking at EKS or other cloud provider managed KDS offerings?
So far, yes. I think there is reasons why we went with kops. I mean, to start with, there was nothing available in AWS when we started, but also we have much more flexibility, and actually the overhead of not managing the control plane is not that much. And yeah, we have flexibility. For example, we can use alpha features. We can use DEX as the authentication. And we can keep up with versioning much better than EKS is doing at the moment. I think we're very interested in the cluster API in general. Sounds pretty powerful and interesting for the future. I know that kops is also going a bit in that direction. But so far, we had a moment where we were doubtful because kops wasn't keeping up with the new versions of Kubernetes. But the project has really improved, and there's many more maintainers. It's much more active. So at the moment, we're pretty okay with it. Any other opinion?
Oh, I agree. Okay, so I think we have another question. How are you seeing kops adopting cluster API?
I think I mean, personally, I think I heard that they want to go towards this kind of model with a kops server, and then a definition that would basically spawn the Kubernetes servers. I don't know how far, I haven't followed closely, but I think this was the idea, and it's been the idea for quite a long time, but it just hasn't been time to go there. And they were talking about sort of adopting or using the cluster API for the kops server component.
And but also again, to remove, since the cluster API will be able to talk to Amazon and do all this provisioning, they can reuse this part and don't need to maintain it themselves anymore, which I think will improve the project overall in terms of being able to keep up new versions and new things that is happening.
Cool, thank you. I think we have time for one final question, if there is one. Otherwise, we are done for today. Thank you all for joining and watching. The stream will be available as a YouTube video later on. And we're getting one final question. Are you planning any other kind of testing for a Kubernetes cluster, chaos engineering, etc.?
I don't think at the moment. No.
No.
We're very busy with upgrading and testing scalability and other. I mean,
And
there's a lot of
general functionality. I wanted to say something, a remark, but I will keep that remark for myself.
But I mean, I think it's fair to say that Kubernetes is keeping quite a quick release cycle, and just to be able to test it out and make sure it doesn't break anything for our users and staying up to speed is taking a lot of effort from our side, along with other things we want to do, of course, because this is not the only thing we do, even if that would have been nice.
Yes, I think rather than going personally for me, rather than going the chaos engineering part, I would be more interested in to see how networking performance is doing if we would go the eVPF way and even remove kubeproxy. I think that is more interesting and more important in terms also of user experience.
I think we did one experiment with chaos engineering. We unleashed, during an internal conference, the company, we unleashed our users. We asked them to come and break Kubernetes on a test cluster. Oh boy,
did they break it? And,
yeah, that was very successful. And actually that was just by simply exceeding those limits.
Yeah, they deployed more than the 3,000 pods per namespace, which then made etcd become read-only. And it took us a lot of days to trying to find out how we could recover from such a state.
So, I mean, I guess that's a good learning. If you want to know what breaks, then let loose your users, because they have all the ways of breaking your cluster.
Which then also like shows that rather than doing this kind of chaos engineering is how can you protect yourself from these things happening? And for that, yeah, there's the answer is available to testing it during application with the webhook and OPA and Gatekeeper.
Okay, so that's all for today. Thank you all for joining. Thank you, Simone. Thank you, Federico.
Thank you.
I would like to say, if anyone else has like a tech talk that you want to do, feel free to reach out to us on Slack or in Twitter, and let's schedule something. Or if you are willing to join and tell us about your cloud native story, then we're also doing a session around that. So feel free to reach out in those channels, and we'll figure something out. Thank you for joining, and thank you for today.